Hello mate. I'm going to show you how to create a hexagon grid for Unity. This is what it's going to look like. To begin, start Blender. Start a new file and delete the cube. Then add a cylinder mesh. Change vertices to 6. In edit mode, scale Z 0.1. GZ negative 0.1. Press period to center the pivot. Last thing, rotate it negative 90 degrees on the x-axis so it fits Unity's coordinate system. Save the file in the asset folder of your project. Let's change some import settings. Change normals to calculate and a smoothing angle of 0. Don't import the materials. Get rid of the rig and animation. Create a new material and add it to the hexagon object. Now turn the hexagon into a prefab. Then delete it from the scene. Create a new empty game object. Also create a new script. Attach it to the game object you just created. Now we can start coding. We need some variables. First, our hexagon prefab. Then width and height, which is the size of the map. They should be uneven so there is a hexagon exactly in the middle. We also need to store the width and height of the hexagon model. You find those measures in Blender. Add a variable called gap for an optional offset between the hexagons. Last variable we need is a vector 3 that defines where the first hexagon will be placed. Of course we will need some functions. We start by adding the gap offset. Then calculate the start position. And finally create the grid. To add the gap we simply modify the hexagon measures by increasing them. Next function will be the calculation of the start position, but we write that one later. Let's write the grid creation first. Add 2 for loops and iterate through height and width. First we instantiate our prefab. Then create a vector 2 that stores the grid coordinates of that hexagon. Now we need to turn the 2D grid coordinates into 3D world coordinates. We create a function for that in a moment. Let's add the hexagon as a child to our world object. Optionally rename it. Now we create the function that will translate the coordinates. Let's have a look at this picture to see what we have to do. As you can see, every second row has an offset on the x-axis. It is the hexagon width divided by 2. So we create a variable for the offset that is 0 by default, and if the y-coordinate of the grid position is not divisible by 2, we change the offset to hexagon width divided by 2. Now we calculate the x-coordinate of our world position. It is not as complicated as it may seem. Start position will be the top left corner of the map. We have not defined where that position is yet. Grid position x multiplied with the hexagon width moves the hexagon along the x-axis. Offset moves every second row a bit further on the x-axis. For the z coordinate we also begin at our starting position. Then we need to move the hexagon backwards along the z-axis. Remember that the 2dy coordinate is the z coordinate in the world. Since the hexagon does not move a full hexagon height, only 3/4, we have to multiply by 0.75, which is equal to 3/4. Finally, just return a new vector with the coordinates we just created. Y stays 0 because all hexagons are on ground level. Finally, we can set the position for the top left corner of the map. Of course, you could just enter a position manually and skip this. But this calculation makes sure that the center of the map is 0, 0, 0 in world coordinates. The idea is simple. Right now the top left corner is in the center. So all we have to do is move it on the x-axis and z-axis. Calculating this new position is what we're going to do now. Again, we need to include an offset. We check if the center hexagon is in an even row. If not, then the starting position needs an offset. Currently our starting position is 0, 0, 0. To get the correct x coordinate, we just have to move left. The distance is hexagon width multiplied by half the grid width, and a bit further depending on the row number. Don't forget these brackets, so the result of the division will be an integer. Calculating the z coordinate is similar. The distance between two hexagons is 3/4 of a hexagon. So we just multiply that by half of the grid height. Now we can create the new position vector. We don't need to change the height, so y stays 0. That's it. Time to see the result. But first, add the hexagon prefab to the script. Thanks for watching. If this video was helpful, please give it a thumbs up. Goodbye.